Before we get started in section 9.2 covering special right triangles, you will want to go to my website for chapter 9, and at the bottom right under resources, you want to download the file called Special Right Triangles Exploration. And so I've uploaded it as a PDF file, and I will show the problems on the screen as I go through this lesson. But if you want to print that out instead of trying to write it from the screen, you may do that. So I'll pause for a few seconds. You can pause the video and go check that out. So once you've done that, the front side of the page will have 4 problems shown here on the screen. Each one of them has a missing side of a right triangle. And I'd like for you guys to use the Pythagorean theorem to solve for the missing side. So in number 1, we're missing this side right here, which is B. And that is one of the legs. On problem 2, you're missing the hypotenuse. Problem 3, you're missing a leg. And problem 4, you're also missing the hypotenuse. So if you can go ahead and pause the video. And when we restart, I will go through the answers. And what we are looking for with these problems is we're solving using the Pythagorean theorem, but we're looking for patterns that might emerge in the numbers for each of the variables. So if you want to go ahead and pause the video. Okay, if you are back, hopefully you have solved each one of the first 4 problems here using the Pythagorean theorem. And to save a little time, I've already worked through the solutions. So on number 1, we have B as one of the legs. So if we write the Pythagorean theorem, B squared plus 3 squared equals 6 squared. Keeping in mind, it doesn't matter which leg is A and which leg is B. So if you want to reverse this and do 3 squared plus B squared, that's also fine. And so when we solve, we get B is equal to the square root of 27, and simplified, that is equal to 3 root 3. And if you have any issues in this lesson, I'm assuming you're already fairly comfortable doing or simplifying radicals. So for example, here, when we split the square root of 27 into 9 and 3, and then 9 splits into 3 and 3. And so using radical prison, we said that the only way a number can escape is it works in pairs. And so he escapes and he dies, and that leaves you with the 3 outside and the 3 inside. So for the sake of what we're doing now, we are not going to go through this again. If you need some assistance or some extra practice, we can talk about that at a later time. And so we find the missing side for number 1 is 3 times the square root of 3. We repeat the same process on number 2. We have 4 squared plus 4 root 3 squared equals 8 squared. I do want to look at this particular part of the Pythagorean theorem because we did not spend a ton of time on this prior to break. And so you end up getting 4 root 3 squared, and that's going to require a little bit of simplification when you multiply these out. Something to keep in mind when squaring something, you are multiplying that number times itself. So 5 squared is equal to 5 times 5. X squared is equal to x times x. And so 4 root 3 squared is equal to 4 root 3 times 4 root 3. And going back to some of the stuff before break, we said that when you multiply 2 radicals together, you're only allowed to multiply the numbers on the outside with outside and inside with inside. And so if we do that, we get 4 times 4, which is 16. And then root 3 times root 3 is the square root of 9, which ends up being 3. And so out of that, we get 4 root 3 squared is equal to 48. And so you can see where that 48 comes from here. And then we continue solving, and you get C is equal to 8. And so 8 is our missing side. So one of the things I want you to look at is how the missing sides, in fact, how all the sides relate to each other. And so what we will talk about, these are actually what are called 30, 60, 90 triangles. And we call them that because the 30, the 60, and the 90 are just the measures of the angles. And so what we will talk a lot about is when you have a 30-degree angle, we will discuss or reference the side that's across from the 30-degree angle as matching up with that 30. And the side that's across from the 60-degree angle matches up with that. So we always pair a side with an angle, and the side is always the side that's opposite whatever angle we're talking about. And so if you have your right angle, the side that's across from the right angle will always be the hypotenuse. So on number 1 here, we've got our 30-degree angle here, and so the side across, let's clear some of that out, make it a little easier to see. And so the side that's across from the 30-degree angle in this instance is the 3. And then a different color, the side that's across from the 60-degree angle is the 3 root 3, and the side that's across from the 90 is the hypotenuse, which is 6. And so one of the things you might notice is that the side that's across from the 30 is half of the hypotenuse. And that is not by accident. That is actually part of one of the patterns we were looking to find. If we slide over to the triangle on the right, number 2, again, let's get rid of all that junk and color code these. And so we look at the side that's across from the 30. The side that's across from the 30 is 4. The side that's across from the 60 is, well, again, let's back up. Let's do some different colors. So the side that's across from the 30 is the 4. The side that's across from the 60 is the 4 root 3. And the side that's across from the 90 is the positive 8. And again, it seems like that same relationship holds, where the side that's across from the 30-degree angle is half the measure of the hypotenuse. And then you'll also notice, if you look at the two, let's clear all the ink off here. If you look at the two legs, it seems like whatever side is across from the 30-degree angle is exactly the same as the side that's across from the 60-degree angle, except the side that's across from the 60 has a root 3 with it. So same thing over here, you'll notice the side with the 60 has a 3 root 3, and the side that's across from the 30 is just a 3. So let's look at numbers 3 and 4 to see if that pattern holds. And so on number 3, again, doing the Pythagorean theorem, you get a squared plus 15 squared equals 30 squared. And we solve, we get the square root of 675, which is extremely annoying to simplify. But if you can do that one, you can pretty much do any of the ones we're going to run into in class. And so you simplify and you get 15 root 3. And it looks like that pattern we discussed in the numbers 1 and 2 holds here, where the side that's across from the 30 is 15. The side that's across from the 90, the hypotenuse, is twice as big as this side that's across from the 30. And the side that's across from the 60-degree angle, 15 root 3, is basically the same as this smaller leg, 15, but multiplied by root 3. And so coming back over to number 4, it seems like whatever pattern we came up with doesn't hold, but it actually does if you look closer at the numbers. And so the side that's across from the 30-degree angle is 2 root 3. The side that's across from the 60-degree angle is 6, which doesn't seem to match up with our pattern. But over here, we said that the side that's across from the 60-degree angle will always be the same as the side across from the 30, except multiplied by root 3. And if we come over here and take that smallest side, 2 root 3, and I multiply that by root 3, same rule we said before, you multiply number on the outside times the outside, inside times the inside. Since there's nothing on the outside, we just say that's 1, so 2 times 1 is 2, and then root 3 times root 3 is root 9, which ends up being 3, and that gives us a value of 6. So it seems like the pattern holds. And then the side that's across from the 90-degree angle, which is the hypotenuse, is twice as big as the smallest side here, the 2 root 3. And so same idea, if you take 2 root 3 times 2, 2 times 2 is 4, the square root of 3 has nothing to multiply with, and so the answer is 4 root 3. And so the pattern we hopefully came up with is the first big one in section 9.2, and these are called 30, 60, 90 triangles. And so the pattern with a 30, 60, 90 triangle is, if we look at the side that's across from the 30-degree angle, we're going to call that 1. The side that's across from the 60-degree angle, we're going to call that 1 root 3. And the side that's across from the hypotenuse is 2. So what happens with these particular triangles is the 3 sides are in a ratio of 1 to root 3 to 2. And this is why we spent so much time earlier in the year on ratios. And so the 3 sides are in a ratio of 1 to root 3 to 2. And so what this will allow us to do is it'll save us the trouble of having to do the Pythagorean theorem on every single problem we do, especially here when you've got the square root of 675. I don't want to have to do the square root of 675 or larger radicals like that. I want to be able to just use the pattern, which what we will end up doing moving forward is we will use the ratio 1 square root of 3 and 2, and we will notice that the side that's across from the 30 is 15. And so if we follow the pattern, the side that's across from the 60 will be just whatever this guy is multiplied by root 3. And then the hypotenuse will always be whatever this side is multiplied by 2. So this is video 1. In video 3, we will actually go through some of the examples of these and how we use them more specifically.